Okay, so more things today. Yeah. Alternate series test. So AST. Review everything. We have a divergent test. According to Margot, we have 7 right now. So that's the first one to test whether divergent or not.
These are all just for series, not sequence, right?
Yeah. Divergence test 2. What do we have? Telescoping. Usually it's in fractions. And sometimes it doesn't have to be fractions. Sometimes it can be a 10 inverse and sometimes you have this 10 inverse of a natural log. Sometimes you have this kind of situation, but we're going to talk about that.
Can you zoom in, please?
10 inverse. And the natural log, and I'll show you a couple later, but that's not usually in AB material or BC material. They usually give you fractions. They won't give you something that in terms of 10 inverse and natural log. But in BC, in the Cal 2 in college, they do including some of those, and to see students they can figure out. Number 3 is geometric, right? So the R, right, has to be less than 1, the absolute value R. So in that earlier case, you thought -4/3. No, that's still divergent. You can go to negative infinity. Yeah, this is for if it's R is less than 1, it's a converge. And usually you can do 1 minus R like this, A over 1 minus R. Good? What do we learn on the 4th one? Integral test, right? So CPD, continuous positive decreasing. If you have continuous positive decreasing, then you can do integral for the things.
Wasn't there a test that we would do before integral test? I thought there was one more. Limit test? Yeah, don't we do limit before integral?
There was some easy one. It's called P series.
Oh,
it's 1 over n to the P. They teach you at the same time. This part is teaching at the same time. P is greater than 1. Then they converge. 6. What are the tests right now? Direct comparison test. 7. Limit comparison test. And then what you're going to do is either both converge or both diverge. Depends on what you compare with, right? Both converge or both diverge. And this one has a bigger and smaller situation. That sentence you write yesterday, I'm not going to write it. So that's just that sentence, 2 sentences. That we say we compare the 2 series, right? And it's... Oh, sure, I read it out for you. Somewhere here in the textbook. If the larger series converge, then small series must also converge. If the small series diverge, then large series must also diverge. Do you remember that? Do I need to write down or no? No? Okay, good. I'm lazy anyway.
Did you write quotes? You were gonna write it.
Yeah, just those quotes that we talked about yesterday. So, quotes from yesterday. Okay, so 8th, we're gonna talk about alternative today. And we're gonna also introduce that next week is 9 and 10. One of them is not on AP exam, but one of them is super, super important. It's called ratio test.
Racial tests.
Yes, exactly, yes, racial. We're testing to see what.
What's the, wait, that says alternating?
Yeah, alternative series. This is today.
Alternative series. That's what we're doing today?
Okay, that's what we're doing today. And we're also gonna talk about the remainders of that. So we're gonna talk about remainder. That one's really hard to understand, but we got this. We got this.
So remainder is a whole different series.
No, remainder is the only belong to alternative series,
Oh, okay.
or they call it error. Also, and we're gonna talk about that. Focus on that today. So this is today.
All right.
Ratio test and root tests is Monday. Okay, so this is a Monday. Monday. So 10 different tests. Now, what can you tell me about Bobby? What can you tell me about alternative? Alternating. What does alternating mean?
Different.
Oscillating maybe?
No.
Variation.
Why would oscillating?
Switching back and forth between what?
Are you saying alternative or alternating?
Alternating.
Oh.
Sorry, my language skill is bad. But it's alternating series. So we call it alternating tests. Okay, alternating series tests. So AST, so we have DCT and we have LCT and then we have AST. AST is alternating series test.
Can you repeat that? Because I can't read that.
Which one? This one is direct comparison test would be DCT. So we're gonna shorthand this so that way you don't have to spend a lot of time to writing. Limit comparison test is gonna be LCT, and alternating series test is gonna be AST. AST has so we're gonna address this here. They say let a to the n is greater than 0. The alternating, I cannot say that word. Alternating series. So for example, there are two types. N equal to 1 to infinity of -1 to the n to the an.
We've seen that before.
We've seen that before, but we just didn't do anything with it. N equal to 1 of -1 to the n plus 1 to the an. Now, the only thing is this part is what's called alternating. But when you're doing the test, when you check the condition, you ignore them. Because due to you have any type of -1 to the n or -1 to the n plus 1, you can call it alternating series. Then you can do alternating tests. But alternating tests must test two different conditions. It has to be first condition first, but we're gonna ignore. You can ignore the blue part because that just allow you to take alternating series tests. Does that make sense? You ignore. What do you mean I ignore it? Is I only look at two things. The first thing I'm looking at is limits as n approach infinity of a to the n must equal to 0. Must equal to 0. If it doesn't equal to 0, then you are automatically diverge.
If a equals 0, then
Wait, can you zoom in on all of that, please? So alternating series is always going to be either diverging or converging on theory.
Yeah, but you have to fit in those two conditions. So this is the conditions, right? So condition says, I don't care about the -1 to the n or -1 to the m plus 1. I don't care about that part. I only care about that part just told me I can do AST. Now AST, so that's the first condition. It has to be alternating in order to do the alternating test, series test. So now limit n approach infinity, a to the n must equal to 0. If it does not equal to 0, then you automatically diverge. You can have that happening as well. The second thing is must be decreasing, which is the way to prove in decreasing. There was two ways. Is one is proving this.
The first condition is just like a divergent test, right?
Yeah, limit n approach infinity, it must equal to 0.
What are these the conditions for?
But divergent test is test for divergent. But in this case, just limit n approach 0 has to be limit n approach to infinity of a to the n must equal to 0. So a to the n plus 1 less to a to the n for all n. What does that mean? That means the term has to be less and less and less and less. So it has to go smaller and smaller and smaller in term of value. I don't care about the sign. I only care about the term itself. Itself is an plus 1 or a to the n. You compare two terms. Always going to be less than less. So like say it's 10, 5, 5 over 2. Something like that. It keep on going. 5 over 4, 5 over 16. So it keep on going. Yes.
Are these the conditions for it to converge?
Yes.
And what's that say on the right side?
Must equal to 0. It's just same thing. It just kind of address that.
Wait, so are these the
Two conditions.
Are these the requirements to use the test, or are these like the tests?
This is the test for converge. Let me write down maybe better. When two conditions are met. Does that make sense now? But actually there was a 3 condition. Well, not a 3 condition, but the first condition is kind of included, right? So it has to be alternating. So it has to be alternating. That should not be a condition. Jonathan, would you mind putting your phone away? Okay. So it has to be alternating to do those 2 conditions. Because those 2 conditions only for alternating series tests. So we're going to test one. We're going to say, hey, we're going to pick the easiest one. We're going to pick a harmonic. Okay. So we're going to pick a harmonic alternating. So you guys remember harmonic is 1 over n. But now what I'm going to do is I'm just going to put a alternating in the front. So it'll be -1 to the n plus 1. Do I care if it's n or n plus 1?
No.
No, because that just, the first term is negative or second term is negative. It doesn't matter. It's just going to switch back and forth, back and forth, back and forth, back and forth. So then in this case, you say, okay, well, -1n to the n plus 1 over 1 to the n. So what you're going to do is you only pay attention to this part. It says, now you can, right? Now you can do AST now. Now what happened is you only focus on this part is the focus.
Yeah.
Now focus, then you say, okay, well, is limits n approach infinity of a to the n is approach 0. And you're going to be like, yeah, 1 over infinity is equal to 0. First condition, true. How about second condition? A to the n plus 1 is less than a to the n. So in this case, is 1 over n plus 1 is less than 1 over n.
Dude, does that say less than or equal to or just less than?
Less than. Oh, less equal to. Sorry, but less than equal to. I just want to make sure. Yeah, it's less equal to. And you're gonna be like, okay, just imagine you plug in 1. 1 is greater than 1/2. True. 1/2 is greater than 1/3. True. And it will true always. So this is true always. So check. So since these two conditions are met, therefore it's converge.
So A doesn't need to be converted.
Wait, 1/n
So A converted.
Huh?
1/n.
Yeah, 1/n does the alternating series.
Yeah.
How did we get the condition 1 to be that?
Because I only focus on limit n approach infinity of 1/n. And this one we know that's true is equal to 0.
But if 1/n divergent but alternating, it converges because half of them are going to be negative.
That I understand.
So what's your question?
But it still doesn't make sense how that would work if it's just multiplying by 1 or -1.
But
I
then
mean,
if
because you're adding them, you're adding
the
you're adding
divergence,
fractions.
and the divergence, it shouldn't be equal to 0.
So think about this. If it's a harmonic, it's 1, right? And minus half, right?
Plus 1/3 minus.
And plus 1/3 minus 1/4, right? So it's convergent toward a value.
Yeah.
Okay, yes, Jonathan.
Bobby had a question.
Okay, yes, Bobby.
How do you find
Huh?
you want to even find what it converges on?
No, you just have to tell me it's convergent or divergent, and how do you do it?
We wouldn't be able to find what the converges on off from that, right?
Yeah, we don't. We're not worried about that.
Okay.
So it's super easy. So you're gonna see it's getting less. You start taking away, right? You got adding something, but you're taking away something less. You're adding something, you take away something less. And keep on giving takes. So if I have 1, right? If I have, let's just say if I have a black here, that this is the length of 1, but you're taking away this much. And you're gonna add a little bit more, but a little bit more is not overcome the 1 - 1/2. So it's gonna get less and less and less. So when the harmonic is diverge, but alternating harmonic is actually converge.
Okay.
Because it's taken away. You're adding something, take away something. You're adding something, take away something. Adding something, take away something. Yes.
I swear to God, I think you do a better job of explaining this in Calc 1.
I agree. I also agree.
Well, because I'm trying to be really slow. But in Calc 1, I'm trying to rush through. Yeah, we had to teach the first semester Calc 1, which is usually, I don't have to do it next year because I don't have to worry about it. Okay, so does that make sense? Okay, I'm going to give you something that you can see and that you can do, and you're going to compare whether that's true or not. So,
So yeah.
Manufacturing automation was simple.
oh. I'm going to pick a question from here because they have better questions. Okay, so the question I'm going to pick as this one. It's going to be summation of n equal to 1 to infinity of -1 to the n of n squared over n plus 1 factorial.
Oh, wait, we gotta focus.
I'm gonna give you a second case. So this is a second case. Is a negative 1 to the n of 2 to the n over 4n minus 1.
Wait, does it have to be less than in every single spot, or does it have to be less than like? Because we were talking about because it goes up and then it continuously, right?
Yeah.
So
It just, you don't need to worry about alternating part. You just have to worry about the thing.
We're not worried.
We're worried about the second condition of
And
an plus 1 being less than an. That's true in almost every case, but not the first few.
So if you ignore the negative 1 to the n, so it'd be 1 squared over.
Put it in decimal.
yeah.
So it's gonna be 1 squared plus 1 squared over 2, and then 2 squared. It's gonna be 4. So actually going up
But then it goes back down.
and go back down. So that second condition is not filled, right?
Okay. I was making sure.
Because they say the condition has to be for all n.
All right.
So,
Wait, no.
same
If it doesn't meet the second condition, we'll have to.
Yeah. It's gonna be diverged.
So just because it does one bump up, it's divergent.
Well, that's what the condition says. That's what condition says. They say it has to be for all n. Converge when 2 conditions are met.
How does that even make sense? Because if you started at n over 3, if you start at n equals 3, then it would converge. How does that make sense? How is adding?
Wait, no. Okay, so I'm taking it back. If you have n plus 1, if n equal to 1, you compare the second term to the first term. What is second term to the first term? Let me see. Second term to the first term.
2 over 3 is the second term. Half is the third term.
So it's getting less? No. Hold on a second. Let me think about it.
Could you just put it in decimal real quick?
Sure. Let's do that.
But it only does it for one value.
N squared over n plus 1.
Because it would, using that logic, it would convert if you started at n equals 3.
So x squared over, what is it? X plus 1 factorial?
Yeah.
Factorial, what's factorial? like right here. So
It's literally that little bump that's saying it's not converted. Which doesn't make sense. Because if you start at n equals 3, then it would be converted.
yeah, so there is a increasing then decreasing is not decreasing. So for me, I'm not entirely sure, but I think it doesn't work.
Well,
But I'll get back to you.
Maybe it just doesn't guarantee that it's convergent then.
So that's a part I'm not sure. But this is the part I kind of iffy about. So I'm gonna double check before I tell you. So let's ignore this part.
Do you see what I'm saying though about the whole like if you start at n equals 3, then the condition is
Yeah, but the problem they never said that. They never say that here. They say n equal to 1. Start at n equal to 1. So you compare 2 and 1. You compare 1 and 2, then there is actually an increase.
But it wouldn't make sense by adding those two values that would go from convergent to divergent.
It's not.
No, it's not. It's actually not.
Nothing makes sense.
Okay, let's hold on for this one. And I'll double check, make sure. This one I know for sure. This one I know for sure. This one I'm not sure, so I'll get back to you tomorrow. No, Monday.
You can get to us soon.
Yeah, you
know
said
what's
it.
up?
What's up?
Yeah, I can get you tomorrow too, but nobody ever answer, nobody ever reply in the WhatsApp. Everybody's like quiet. My I don't know if you in my Cock One group chat, every day is 200 message.
Oh wow.
Yeah.
Every day.
We're like, they took all of the energy. And
Here,
so
wait,
now
we
we
have to
none.
take a video of your son telling us the answer, and then we'll.
That's true. So how about this one? This one's converge or diverge. That one is easy. This one's diverge. Why?
Failed the limit transfer.
Fail the first one, right? Okay, we're gonna give you the next one here. I wanna see if I can pull out the next one here. Let me see what I can do with next one.
Wait, so we're gonna work on this.
So next one is gonna be this one. So we're gonna start at n equal to 2 now, so that's better. -1 to the n plus 1 to the square root of n plus 1 over n minus 1. This one's actually doable. Remember, there's two ways to proving the decreasing, right? Two ways. First way is compare the next term, the easy way. But there is a second way to prove for this case is much better. What's the second way to prove it's decreasing?
Limit comparison? Not limit comparison, like take a limit and evaluate the limit. Or L'Hopital's. Or no. You're just saying something.
What's that? Look, shh. What is it?
It's a derivative.
Just a derivative. Now the derivative of this one is kind of interesting, so we're gonna do it together. So is this alternating? Yes. Can I do AST? Yes. Limit n approach infinity. What time we get off here? Okay, so if n approach infinity here, it's gonna be what? It's equal to 0, right? Okay, so now I'm gonna do a derivative. You'll find out Monday.
Cliffhanger. Yeah, that's what you have.
Because Monday we're gonna talk about the whole remainder thing. That's gonna take a whole period. No, probably Friday.
Yeah.
Bye. Have a good day. You love it, you.
You sound like this. I think it's like every Friday now, so
Yeah.
just to verify. Those missing assignments are like BS. It says I have like 9 missing assignments. I don't know. So.
What's up?
I did not get home until 11:30 last night, and my brain was fried, and I just looked at it, and I know how to do it. I just looked at it, and I was like, and I couldn't do it. Can I just come after school and do it in here?
Yep.
Okay, thank you. Right after school, I immediately went straight for the airport.
Why?
Flying.
Oh, okay. You and Anthony Teeter.
Yeah. He has my old instructor for when I was getting my first license.
Right. But you gotta make sure you understand the stuff, though.
What?
You gotta make sure you got this stuff. But that's a good question. I'm gonna get back to you on that.
That's why I'm gonna come after school. I knew what I was doing. I did not have the mental power to do it.
Okay.
last night.
It happens sometimes.
Like it should be decreasing here, you call this a thumb. Then. You. Left. So what's that? I said listen. And we keep on going. As far as E. 0. Base of 1, well. So it's going to be 1, okay, so -1 over 2 factorial. Which of course is just 2. I don't believe it's 2 factorial, so we just keep the pattern in as well. Next one, everybody, am I going to get a plus or a minus? We get a plus, that's right. Series does that. The only thing that's changing signs is it's -1 to the n. If I increase this to 2, the -1 squared is positive. This becomes what? Over, very good. We can get the pattern really quick. So this will be, next week, this will be negative, then a plus, then a minus. What's going to go here? Here. Over here. Let's do one last one. So negative plus minus plus, and then what? Sure, because we have the fourth term, 4 squared is 16 over, and then it doesn't end. It goes forever and ever. Notice this. This is the same thing as some series where we have -1 to the n times a sub n, where a sub n is all positive terms. The only thing that's changing the sign here is that -1 to the n. Quick show ends, we'll give what the alternating series do. So alternating series is basically just having a -1 to some power that changes the signs. Every other sign is sequential terms. Now, we do have what's called the alternating series test. Here's the test. It's really straightforward. It's not hard to do. It uses some things that we've already talked about in this class, so it's kind of nice. Here's the test for us. for an alternating series. So for some series,
1 minute remaining until class.
for some series, this alternating. By the way, can you get the intro that's going to be alternating series? Okay, this series, of course, if you want to write the first terms, this will be a sub n minus a sub n plus, or a sub n. A sub 1 minus a sub 2 plus a sub 3 minus blah, 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 over to the next. Also, notice what I want to tell you is that a sub n itself, a sub n is so this is also positive. That's the idea. Are you sure you're okay with that? The only thing that would be changing the sign of the name to the name of the school. But get over here. We'll just say, what I'm telling you is that an alternating series has a negative 1 to the power times some other sequence that has positive terms. These would all be pluses if it weren't for the negative 1 to the power. Agreed? So that means that a sub n itself is going to be positive. Cool. All right. So with this as our condition, if a sub n plus 1 is less than or equal to a sub n, say if a sub n plus 1 is less than or equal to a sub n, what's it telling you about the sequence from which we get our series? What's it telling you about? It is, say it louder. It's decreasing. Can you explain why it's decreasing? That's exactly right. The next term is smaller. Do you guys understand? We did this like a couple times before, right? Do you understand this is the term right after this one? If the term right after this one is smaller, that means that we are decreasing. So basically it says you're decreasing. So if this is true for all men, which means this is decreasing. And the limit as n approaches infinity is, oh, tell me something, this is gonna be good, right? This is usually the thing that I have you do, the first part of every single series we ever do, I have you do this. What does this have to be, do you think? It's got to be 0. Now, that's basically the divergence test. Now, we don't really use the divergence test here because we don't include that negative 1 and n minus 1, but practically we do. We use it on a sub n. So this is the divergence test. So basically what we're saying is, hey, if your series passes the divergence test, so basically look at the sequence of positive terms. If your sequence of positive terms, when you take a limit n approaching infinity equals 0, and you know that the sequence of positive terms is decreasing for all, and if you know that, then you know that your alternating series is going to be convergent. This is the test. Has to be decreasing. Now, I'll show you one in just a second. Let me recap this before I give you, I'm not going to prove this, I'll give you kind of like a graphical proof for it. It's very common sense kind of idea once you see it, okay? So let me do like a 1 second recap and give you everything about alternating series that you really need to know. First thing, alternating series alternate signs for sequential terms. It doesn't matter whether you start with a positive or negative, typically we're going to start with a positive, but it doesn't really matter. What you need to know about these alternating series is they can always be broken up as negative 1 to some power times a sequence of positive terms. Negative 1 to some power times a sequence of positive terms. Does that make sense? All you have to do for your alternating series test is first, verify it's alternating. Verify it has one of these things. Does that make sense? Verify that. If you can verify it's alternating, then all you got to do is look at the limit of your sequence of positive terms. Look at your a sub n. If the limit of a sub n equals 0, well, you know what? We do that anyway, don't we? That's a divergence test. So if the limit of base of n equals 0 says, hey, you might not be divergent. If the sequence is also decreasing, so you look at the sequence of positive terms, if it's decreasing, what this says, then you're convergent. So all you gotta show is that it passes the divergence test as far as the sequence of positive terms is concerned. Does that make sense to you? And that is decreasing. Have we shown both those things in different times in this class? Lots of we were often in the habit of decreasing. That was for monotonic bounded sequences. We showed that they were decreasing. We showed it for the integral test that it was positive decreasing. Now it's for alternating series. Just don't ignore that. That's even part of it. Just look at your A sub n. If you can show your A sub n sequence is decreasing, then you're good. If you can also show that the limit of A sub n is n versus infinity is 0, that's the two parts of your test. We've done both. One's called the divergent test most of the time. One of them is just decreasing. If you show both those things, then your series converges. Do you want to see why it converges? Okay, remember here that what we're doing is we're adding up numbers, right? We're adding up numbers that alternate signs, which means this. Are you listening? We're going to start with one number. We're going to subtract something. Then we're going to add something. Then we're going to subtract something. Then we're going to add something. Then we're going to subtract something. Then we're going to add something. Then we're going to subtract something. Then we're going to add something. Listen carefully. Here's the whole crux of this proof. If your series is decreasing, you start with the number, correct? Let's assume it's positive. It doesn't have to be. It could be negative. But let's assume it's positive. If you subtract backwards, right? But it's not going to go to 0 because what you're subtracting is smaller than what you originally have. Does that make sense? Now, you're going to add something to that function, but it's smaller than what you subtracted. Then you're going to subtract something that's smaller than you added. Or subtract, here's what it looks like. You start with, let's say we start with 0. Here's 0. After your first term, do you remember this, the partial sum set was it S? We had an S of n for a partial sum. So after your first term, you have a sum S of 1. Whatever that is, you're going to have some sum. If you only you have one term. Make sense? Now, because we know that this is decreasing, you would subtract. Well, here, I get the number 2. After 2 terms, that's what your sum would be. Do you understand that it would have to be positive? If I start with a positive number, I'm going to subtract something that's smaller than that positive number. True? Now, I'm going to add something. Is it going to make it all the way back over here? No. It's got to be smaller. Whatever I'm adding for my third term is going to be less than whatever I subtract from my second. And we keep on going. Because I'm decreasing, I'm getting closer and closer. Do you see that ultimately what's going to happen? I've lost the here is going to this way, this way, this way, this way. Ultimately, what's going to happen is that I'm kind of doing this ping pong match. Have you ever watched someone play tennis, right? Well, you start here and you volley the ball over and some guy moves on and hits it. Let's pretend that these two guys start at the end of the court and this guy hits the ball here and then he hits it backwards and goes to the end and he gets back and he gets closer and he gets closer and closer and closer to the net. And these guys are coming like that. And every time you hit the ball, the guy steps forward a little bit. Does that make sense? They're going to get really close to something. That's what this is doing. It's saying, okay, you're adding, you start with one term. Then you're subtracting something less than that, adding something less than that, subtracting something less than that, adding something less than that. It's going to one sum. Remember that the sums are what we're going to. We're not adding all the rest of these things together. These are the sums. Because you're subtracting numbers and adding numbers back and forth. So sum number 1, hey, subtracted. Sum number 2, added. Sum number 3, subtracted. Sum number 4. Because we're decreasing, eventually I'm going to start adding. Small, they don't make it big. Sure, that makes sense to you. And that's the idea of proving that this is convergent. Because it passes the divergence test, because we're decreasing, and because it's alternating series says, yeah, you're adding and you're subtracting, sure, but you're decreasing, right? So what you're adding and subtracting keeps getting smaller, 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 smaller. Therefore, we're going to get really, 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 really close to one number eventually at term infinity. At term infinity, S sub infinity, that means a limit of S sub n as n approaches infinity. And hey, we did that. We did a limit of partial sums as n approaches infinity. That would be one. That's the. If I explain that well enough, you guys understand the basis of this test. Are you sure? I don't want to leave anybody hanging on this one. Is it clear for you? The whole adding and subtracting and adding something smaller, subtracting, eventually you're going to get down to one. Now, let's go ahead and show how this actually works, okay? I'm actually going to start with this example. So let's show what this one does. First things first. What must we show all the time, every time, for all our series ever? Basically. Oh, okay, doesn't necessarily be possible all the time. Continuity would be for the integral test. You're on the right track for integral test for sure, okay? As far as every series ever, what do we always check first? The divergence test. So let's do that first. So I know these are kind of out of order, but I'm going to always show this one first, because if I can show this one doesn't work, I can just stop. So number one, we're going to take a limit as n approaches infinity of a sub n. Now please listen carefully. When you do your limits and when you check for decreasing, please look up here for right now. Look at this. When you do that, is negative 1 to the n minus 1 part of your a sub n? Oh. So basically, that just says it's alternating. So right here you go, okay, you're alternating. Now look at this, the rest of your series. That is your a sub n. So when I'm looking at this one right here, I'm looking at this one. What part says it's alternating? Take that part away. I'll put a little side note here for you. Recall, a sub n in this case is 1 over n. It does not include the negative 1 to the power. That's why I made such a point about you can always pull out the alternating part. You can always have a series of positive terms, or a sequence of positive terms, that a sub n. Should have you understand that concept. Okay, so do we need the negative 1? Do we need this negative 1 to the n minus 1 inside my limit? No. All we've got to do is, this is what it says, folks. It says the limit of a sub n, not the limit of the whole thing. Who cares? It's just this little piece right there. Shows decreasing. Well, that's just the a sub n, not the piece. Who cares? We just want to show that the sequence is actually decreasing. That's the idea. So for us, I'm going to write this down a little bit. Let's take a limit of practically what you do. Right, what that can be. Tell me, what's the limit of 1 over n as n approaches infinity? Does that pass our version of the divergence test for this? Did I say our version of the divergence test? Because we're not really taking the limit of the whole thing, it's just the sequence of positive terms, and that's what we're taking the limit of. So it's kind of our version of it for this. So that's brilliant. What's the next thing that we should do? We've got to show decreasing. So this is a two-part test. It's do the version of the divergence test, and then secondly show that this thing is actually decreasing. So number 2. How in the world do we do that? You could do it a couple ways. It's probably, and sometimes we're going to be using the derivative. Remember the derivative idea should be decreasing here? You call this thing a function, you take a derivative, and if the derivative is negative, then the function is decreasing. No problem. Well, we can do that, or sometimes it becomes a little bit, just a little easier. For instance, here's what I would say. Because it's so fast for this one, here's how I would do it. A sub n plus 1 is equal to 1 over n plus 1, correct? You know, I just asked, correct, but you see where that's coming from? A sub n plus 1 says, hey, you plug in n plus 1. Is that less than or equal to 1 over n? For all n. And is this equal to a sub n? Sometimes it's easier to do this than it is a derivative. So right now this says that a sub n plus 1 is less than a sub n. That shows that it is decreasing. What about the fact that it's a harmonized series? Right now. I want to make sure that this is okay with you, all right? Do you understand that this is an alternating series? Hello, yes, no.
Yeah.
What's that? Alternating. Are you okay that the limit of the sequence for which our series is built as far as a sub n is concerned is equal to 0? Steps. Are you okay that this sequence is also decreasing? So, a sub n was 1 over n. We showed that the limit of that sequence is 0. We also showed that this thing is decreasing because, well, if I add 1 to this, I added 1 over n plus 1. That's always less than 1 over n for all n greater than 1. Really? Okay. Well, that's equal to a sub n. So now I've shown that a sub n plus 1 is less than a sub n. That's decreasing. So I specify this. By the alternating series test, we have something that's alternating. We have something where the limit of our sequence is 0. We have something that is decreasing. Tell me something about this series. It converges. It absolutely